Hey everybody, I'm Meteorologist Gavin Sandel. Weather's impact stretch from the surface all the way up to space. There are variables us meteorologists use when studying the change of something over altitude. One of this is lapse rate, the interplay between height and temperature. Here's the full definition behind me, and it's defined as the rate at which air temperature falls in terms of altitude. And you got to think, let's say you're going up a mountain, typically the temperature goes down as you go up in altitude. That's the lapse rate. And the one caveat to that is that lapse rates vary depending on the amount of moisture in the air. And that gives us two types of lapse rates that I'm going to cover in this video. The first one is dry adiabatic lapse rate. That's in dry air, an idealized scenario where, let's say, there's no humidity at all. That's 9.8 degrees Celsius per kilometer. So every time you're going up a kilometer, or about 0.6 miles, you lose 10 degrees Celsius or about 18 degrees Fahrenheit. So when there's moisture, that temperature change isn't as crazy. It's about 6 degrees Celsius per kilometer. And that amount of moisture and that lapse rate actually has pretty big impacts in terms of what's going on with the types of weather. So I'm going to put this into perspective for you guys. Let's divide the screen into two different environments. You have a dry one on the left and a moist one on the right. And both of them are going to be at the same temperature, about room temperature, 22 degrees Celsius. And if you go up 1 kilometer, everything's staying the same. You could tell that the dry atmosphere has a bigger slope. At 1 kilometer, you're at 12 degrees Celsius now rather than 16 degrees Celsius, which is a little bit warmer in that moist air environment. And it has pretty big things for thunderstorms. If you do have a lapse rate that's larger than the dry adiabatic lapse rate, that can spell a lot of thunderstorms and unstable air. That's the first major impact that we have for lapse rate. High lapse rates allowing for thunderstorm development, and you could also have lake effect development on that front as well. And precipitation as well, if you have lower lapse rates, you'll see typically not crazy severe components, no hail, no anything like that, just more stratiform, calm rain showers. So precipitation has to do with that as well. And then when we have negative lapse rates, that's actually the increase in temperature for height. We get what's called a temperature inversion, and that actually could play a pretty big impactor in air quality, where pollutants can actually just hang around in the atmosphere, the lower atmosphere that is, for a very long time. So lapse rates can have a very big impact on our society as a whole. But the one thing that we're looking at right now for our weather today and Tuesday as well is lake effect. And that is just defined as winds going over warm water. And so in this scenario today, our water temperature is about 23 degrees Celsius, 75 degrees Fahrenheit. And when you have cold air, which is what's moving over that, in this case 10 degrees Celsius, that's a 13-degree change over a kilometer. And that is much higher than what is the dry adiabatic lapse rate. So when that happens, air will become very unstable, and then you'll tend to have those clouds moving over with scattered rain showers, and more importantly, during the winter, a lot of very heavy snow showers as well. So what's resulted in the next couple of days has been a blend of scattered showers across Trumbull and Mercer counties, with the rest of the Mahoning and Shenango valleys rather dry. It's a classic wintertime pattern, but just a couple of months early. For Weather 101, I'm Gavin Sandel.